Today we are going to be doing problem 22.41 in the 10th edition of the textbook, and this is also quite similar to example 22.4 if you're ever super confused as to what is going on here. So the idea is that we have three charges here, all have the same charge plus Q, and we're trying to figure out what is plus Q for this situation to be in an equilibrium. Whenever we have equilibrium, that means we have a balance of our charges. A balance of our forces. So if we look at this charge here, which we're going to call charge number 3, we have the tension going up along here, we have the gravity going down here, and we have our electric force that is pushing or repelling our charge to the right. So this is our electric force. Now we can say that this electric force is caused by charge 1 on charge 3 and by charge 2 on charge 3. And we have Coulomb's law to figure out exactly what the equations for these forces is. So first thing we want to do is draw out our forces in our 2x2 plot. So we can figure out which ones are along the x-axis and which ones are along the y-axis. So here, the only one that's not nicely on one of the two axes is tension. So we look at the angle, and the opposite here, this is going to be t sine theta, and this one is going to be t cos theta. And if you forget how to do that, you have to remember your SOHCAHTOA. So the sine is going to be the opposite, right? So sine, opposite to the angle down there. If I draw that out on my diagram here, I have t sine theta going to the left. I have my electric forces going to the right. I have my gravity going down, and then I have my t cos theta going up. So now, for this situation to be balanced, I know that t cos theta has to be equal to my gravitational force, and I know that t sine theta has to be equal to my electrical force. I can write that out. So t cos theta is equal to mg. T sine theta is equal to F13 plus F23. Right, so here I have two unknowns. I don't know what the tension is, and I don't know what, well, specifically these forces will be. I don't know what the charge Q is. That's okay. Two equations, two unknowns. I can figure out what everything is. So here, T is going to be equal to mg divided by cos theta. I'm going to plug that answer into this equation, and I get mg sine theta divided by cos theta is equal to F13 plus F23. Now I'm going to use Coulomb's law to figure out what those two are. So here we have F13 is equal to KEQ1 Q3 over R squared in the r hat 13 direction. So what is r hat 13? Well, that's the vector pointing from 1 to 3. So that's in the positive x direction. So this positive x hat. And what is r? Well, r is the distance between 1 and 3. So if I called it x, then here r is equal to 2 times x, right? And I can say that, well, I know that x is equal to L sine of theta. So if x is equal to L sine of theta, r is equal to 2L sine theta. I just plug that in here, so I get F13 is equal to KEQ1 Q3 over, and then I just plug that in, and that becomes 4L squared sine squared theta. And I know that my charges all have the same value, so that's just going to be q squared in the plus x hat direction. Okay, so then we have force 2, 3 that we care about. Same thing, so the charges are the same, so that's going to be q squared, and we look here, r hat 2, 3 is also pointing in the plus x direction. And then the distance between them is just going to be x, right? So it's distance here to here, which we know to be L sine theta. We square that and we get L squared sine squared theta. So we just have to add up F13 and F23. We do that by just taking everything that's in common out to the left, so KEQ squared over L squared sine squared theta. And then here we have a 1 over 4 plus a 4 over 4. Right, so this is just multiplied by 1, this is multiplied by a quarter. And that is going to give us 5 over 4 KEQ squared over L squared sine squared theta. And remember that this is going to be in the plus x hat direction. Now once we have this, we just have to plug it back into our equation that's way up here. And the last thing to do is just solve for a q. So we take this, bring it up here. So we see that mg sine theta over cos theta is equal to, and then all this stuff. All we have to do is isolate for q. That's pretty simple at this point. Okay, so that is our answer for q. And now you just have to really plug everything you have in, like all your actual numbers, and you should get 1.98 microcoulombs.